I welcome you all for the session of properties of convolution sum. And this is coming under B2 syllabus, and this is studied by 4th semester ECE students under module 2. This can be studied by any other students also who wants to know really the convolution sum, right, in signal processing or doing projects, mini projects, or MTech students, or even PhD signal processing students, right? This is you can see this. This is very useful, right? This is my lecture 4. In all my previous 3 lectures, we discussed about the LTI systems representations, linear time invariant systems representations, right? The LTI systems representations where x of n is input and y of n is output and h of n is impulse functions. Now, previous class we discussed x of n and y of n how exactly represented in terms of shifted impulses we have shown. And that formula we got it as convolution sum in this case. Right? We are discussing with discrete time. Then we have also discussed convolution sum in 3 ways. Finding out output, y of n output. In 3 ways we did. One is graphical way of considering x of n and h of n, and we got output. We shown that. Second method we have shown by multiplications method. By giving 2 sequences, x of n some 3 sequences, h of n from 4 sequences, we have seen calculated output by by multiplications method, right? And also third method also we did by immediately within a minute we can check the output of LTI systems or convolution sum by using tabular column methods. All the 3 methods which gives the flexibility in analyzing signals we have seen. Today we will see properties of this convolution sum, which gives again most beautiful 2 properties. Let us deal today: commutative property and distributive property, which gives again more flexibility to analyze any signals, discrete time signals of LTI systems or representing LTI systems. Right? It gives more dimensions. Now, what is that commutative property? Let me see first commutative property. Very famous property in maths, same as maths also. You studied commutative, distributive, associative. Here also same, but along with significance, importance, with signal processing. X of n, linear convolutions with h of n is equal to h of n convoluted with x of n. Take LHS, that is nothing but x of n. xn into hn is equal to h1 into xn. Is 1, 2 is equal to 2, 1, like that, right? Now, this is equal to, take LHS, very simple proof now, right? LHS x1 in x of n convolutions into h of n is equal to, write the formula, standard formula, summations, k is equal to minus infinity plus infinity, x of k into h of n minus k. This is like a convolution sum standard formula, shifted impulse formula. Now, see the second term, h of n minus k, how to get RHS now, right? Substitute h of n minus k as m, h of n minus k as m. Then by doing that, what you will do? You will change summations. Then we get summations k is equal to minus infinity to plus infinity to summations m is equal to plus infinity to minus infinity. We are changing summations from k to m. Just for the simplifications purpose, that's all. Right? In the end, we'll remove this m, we'll substitute k only after getting the output. Now, to get output. Now, what happens when you substitute m as n minus k as m? Then what will happen? When k is equal to minus infinity, now see this? When k is minus infinity, first step, then what will happen? M is equal to n minus k is there. M is equal to n minus, what is k? K is minus of minus infinity. Minus of minus infinity is plus infinity. Therefore, your m is plus infinity. That is your new limits. M is plus infinity next. Then, similarly, when k is upper limit, k is plus infinity, then substitute here, m is equal to n minus k is there. Sub m is equal to n minus, what is k? K is plus infinity, you are saying, plus infinity, plus of minus. Therefore, m is equal to minus infinity. Therefore, your new limits becomes m is equal to plus infinity to minus infinity. when you change summations from k is equal to minus infinity to plus infinity, you will get your new limits, right, with summations m as plus infinity to minus infinity, reverse. Now that's what my next step. Substitute here, you will get LHS x of n convolutions with h of n as m is equal to plus infinity to minus infinity. X of, what is x of, right here, see for example, x of k is there. What is k? K is nothing but n plus m. Sorry, n minus m. That's what I am writing. N minus m. Then, second term you see, what is this? H of n minus k is there. N minus k is substituted as m. Therefore, h of m you will get. That's what this. H of m. Right? And limits changes from n to, sorry, what is that? K to m. New limits. Now it is over. It is of the form. What I will do is I will remove this m. Right? I will throw this m. This is over. Work is over. Since m is dummy variable, right? I will replace m by k because I want formula. I want RHS in terms of k. Therefore, m by k I will do. Wherever m is there, substitute k. X of n into h of n is equal to summations k is equal to, instead of m, you write k. K is equal to infinity to minus infinity. X of n minus, what is m? M is k. Replace. H of what is m? H of k. Now, you will get like this. K is equal to infinity to minus infinity. X of n minus k. H of k. Now, summations k is equal to plus infinity to minus infinity is same as plus infinity to minus infinity is same as minus infinity same in minus infinity to plus infinity in case of discrete. See, for example, there is a formula. What is that? K is equal to summations from plus infinity to minus infinity is same as minus infinity to plus infinity. See, no change. Right? This is discrete. Same. That is a formula. Let me apply that. Then RHS is equal to summations k is equal to minus infinity to plus infinity. This is reverse. X of n minus k into h of k. Now, I will write this as h of k first. This h of k is there now. This first I will write. X of n minus k I will write second. Why? Because I want answer. H of k into x of n minus k. Which is nothing but what? Which is nothing but, see, this is standard equations of h of n convolutions with x of n. Your standard convolutions equations. H of k is coming first. Earlier it is x of k into h of n minus k is there now. That is x of n into h of n. Here it is h of k first coming, therefore h of n into x of n, which is nothing but RHS. But that's the proof. Hence the commutative property is proved. What is that? Only 3 lines. First, write the statement x of n into h of n, which is equal to h of n into x of n. Write LHS x of n into h of n. Write the formula x of k into h of n minus k. Summations k varies from minus infinity to plus infinity, standard formula. Substitute n minus k as m. That's all. One more variable. K variable to m I want to shift, and I want to remove this later. Then we get the summations from k minus infinity plus infinity to m is equal to plus infinity to minus infinity. That is shown here. Plus infinity to minus infinity you will get. That's what this plus infinity to minus infinity. X of n minus m, because of this is nothing but k is nothing but n minus m. The other one is similarly h of m. Then m is dummy variable, over, work is over, throw it. Replace m by your original k. Then you will get summations k is equal to plus infinity to minus infinity x of n minus k h of k. Now this is plus infinity to minus infinity same as minus infinity to plus infinity. There is a formula. Then substitute. Then write this as first, this as second. You will get RHS. H of k first, x of n minus k next. You will get RHS. Hence the distribute commutative property is proved. Similarly, let me go for next one more beautiful property, distributive property, which is very, very simple. Right? Here, instead of two signals, we need 3 signals here. 3 signals here. Right? X of, what is that statement says? X of n convolutions with combinations of 2 signals, h1n plus h2n. 3 signals we need to prove this property, this and associative. Right? Name might be, you have seen in maths. Otherwise, now, is equal to x of n convolutions with h1n plus x of n convolutions with h2n. Very, very simple. Now, this needs 3 signals instead of 2, and right side 2 terms you will get. Now what you will do? Take LHS, write LHS x of n, convolutions with h1n plus h2n combinations of two signals in one is equal to write the formula. LHS you take, write the formula. Standard formula for convolutions. What is that? Summations k is equal to minus infinity plus infinity x of k into h1 n minus k plus h2 n minus k. Then split this. Summations k is equal to minus infinity plus infinity x of k into h1 n minus k. Similarly, split second. Summations k is equal to minus infinity plus infinity x of k into h2 of n minus k. Two convolutions you will get. Now this becomes simplified as x of k h1 n minus k is there. This is nothing but standard equations of x1n convolutions with h1n. Similarly, this is standard equations convolution x of n into h2 of n. Right, convolutions of h2 of n. This is therefore which is equal to RHS. Hence the distributive property is proved. Right, what is that? Only two steps. First write statements. You need three signals instead of two. Then take LHS. Then write standard formula. Then split this formula into two summations. Then one is x of n into h1n, which is first this one. Then second summation is x of n into h2n, which is your second summations. For example, this. Right? This over. Now that's all the things. Now this is how properties. Right? I hope I am clear. These properties will give you, properties of convolutions will give you more flexibility. Right? Along with so many methods of doing same signals. Right? To find LTI output. So many methods we are having. Right? To calculate the output. So many methods we are having. Right? Along with this, just include the properties. That gives more flexibility to do any signal better, process better. Right? I hope I am clear. Next class we'll see associative property, which is also very interesting. Maybe it is a little lengthy, and along with other properties also we'll see. I hope by the time I am clear. Right? Thank you. Have a nice day. Please study all these things. Right? Thank you.